Hello, this is the second part of number system for ninth class students. So in first part, we already discussed about the rational numbers and how to represent the rational numbers on the number line and how to find the rational numbers between given two rational numbers by mean method and some single step method or direct method and the decimal expansions of the rational numbers and how to write the decimals in rational form. So those all topics are we discussed in first part. So this is the second part for ninth class students in number system. I mean in the first chapter. So today we are going to discuss about the irrational numbers. So first we need to define what is irrational number. So there are so many definitions for irrational numbers, but according to your standard, you need to understand what is irrational number means. Already I told you there are three types of decimals. The decimal which is called as a terminating decimal, I wrote here TD, and another decimal we can call it as non-terminating repeating decimal. Non-terminating repeating decimal. And the third one is non-terminating non-repeating decimal. Non-terminating non-repeating decimal. So for example, this is 0.32 and this is 0.32 32 like this, and this is 0.3210567857 dot. So this is called as a terminating decimal because after two decimal places it is stopped. I mean it is terminated. And here if you observe it is non-terminating because the decimals are continuing here and only two decimal places are repeating. So these type of decimals we can call it as a non-terminating repeating decimal. If you observe this, it is also non-terminating and non-repeating. Any decimal is not repeated. So these are three types of decimals we can find. So in the previous class, we learned how to make these two types of decimals in form of P by Q, in P by Q form. So we know how to make and how to write in the form of P by Q of the terminating decimals and how to write in the form of P by Q of a repeating decimals. But here another one decimal is there. By using this concept, we can define what is irrational number. Here I will tell you two types of definitions about the irrational number. Irrational number, first definition is a number we cannot represent in the form of a P by Q. I mean in the form of terminating decimal or non-terminating repeating decimal. If you or not represent a number is not in the form of terminating decimal or non-terminating repeating decimal, those numbers are irrational numbers. Here I wrote the number cannot be expressed as the terminating decimal or repeating decimals. Means that number you cannot write in the form of a terminating decimal or non-terminating decimal. So what does this mean? Means if you represent that number as a terminating decimal, you can convert that decimal in the form of P by Q. If you write a number in the form of a repeating decimal, that also you can write in the form of P by Q. It means a number we cannot represent in the form of P by Q, those numbers are called as an irrational numbers. So this is my first definition, but another definition is there. Here, if you see this is root 4 and root 5. If you see this is root 4 and root 5. So 4 is the perfect square number, 5 is non-perfect square number. 4 is a perfect square number and 5 is root 5 is a non-perfect square number. You know that the root value of 4 is plus or minus 2. So plus or minus 2 means 2 is a rational number. But here root 5 is a non-perfect square number. Therefore, root 5 we can call it as an irrational number. Here my second definition is if n is a positive non-perfect square number. Here 5 is a positive non-perfect square number. Hence root n we can define as irrational number. So root 2, root 3, root 5, root 6, root 7, root 8, all these numbers. But here root 9 it is not a irrational because according to my second definition, 9 is a perfect square number. But all these numbers are non-perfect square numbers. Hence, these are all we can call it as irrational numbers. So There are two definitions I explained. The number we cannot express it as a terminating decimal or non-terminating repeating decimal. It means we cannot represent those numbers in the form of p by q. Those numbers are called as an irrational numbers. And a number n, here n is a I mean positive non-perfect square number, then root n is called as an irrational number. Here I given some examples, that is root 2, root 3, root 5, root 6, root 7, root 8. These numbers we can call it as an irrational numbers. So in your standard, there are some properties or concepts are there. Those we require to discuss today. So those concepts here I am going to explain. So what is those concepts means? Here my statement is the sum of two irrationals. I mean one irrational number plus one irrational number is what? This is the first concept. The sum of two irrational numbers is always irrational. For example, we are assuming that the sum of two irrationals is always equals to an irrational number. So this is my statement. You think that the sum of two irrational numbers is always irrational. So you need to justify. You need to justify that statement. But some students, what they will think means root 2 plus root 3 is an irrational number. Here root 2 is an irrational. Root 3 is also an irrational. The sum of these two also an irrational. Therefore, my statement is true. They think that my statement is true, but it is not at all correct. So the sum of two irrational numbers are not at all always irrational numbers. The sum of two irrational numbers are always not an irrational number. Here, my statement is, I want to support my statement. That's why here I have taken one important concept. That is, for example, you take uh, 2, 3 plus root 2. You know that this is an irrational. I will explain you later why it is an irrational, because we are going to prove. So 3 plus root 2 is an irrational, and 3 minus root 2 also an irrational. So now my statement is the sum of two irrational numbers is always irrational. Hence, if you add these two, 2 plus root 2 plus 3 minus root 2, then what happens? These two will be cancelled. We will get the answer as 6. But 6 is not an irrational. 6 is a pure rational number. Because 6 we can write it as in the form of 6 by 1. So hence it is an irrational number. So my first statement is the sum of two irrationals are not at all always irrational numbers. And my second statement is the product of two irrationals is always irrational. That is also a wrong statement. The product of two irrationals is not always irrational, but sometimes it may be rational also, because if you take the same example, these two are the irrational numbers. If you multiply these two numbers, what happened? You see 3 plus root 2 into 3 minus root 2. So if you observe carefully, these two are in the form of a plus b into a minus b. You know that a plus b into a minus b is equal a square minus b square. If you apply this property on this product, what happened? A plus b into a minus b, this will be equals to a square minus b square. Hence, it will be 3 square minus root 2 whole square. Then it will be 9 minus 2. Therefore, it will become 7. So, I am explaining my statement. It is wrong. That is, the product of two irrationals is not at all always irrational. Sometimes the product of two irrationals is sometimes the product of two irrationals is rational number, because here 7 is a rational number. In the same way, the division are the sum and all these four operations. In these four operations, sometimes you will get a rational number. I mean, sometimes the sum of two rational numbers is rational. Sometimes the difference of two rationals is rational. Irrationals is irrational. And sometimes the product of two irrationals is rational. And sometimes the division of two irrationals also rational. For example, if you take 3 root 2 and root 2, these two are the irrational numbers. If you divide these two, what happened? You see 2 root 2 by root 2. So root 2 cancel, you will get as 3. So the division, that if you apply the division operation on these two irrationals, you are getting a rational number. So sometimes the difference, the sum, the product, and the division may be a rational number in between two irrational numbers. So these things every student must know always to know about the properties of an irrational numbers. Yeah, this is the brief introduction about the irrational numbers. But in your syllabus, the concept of real numbers. What is a real number? What is a real number? That is very, very important. How can we define a real number? Already, what is the definition of a rational, you know, and what is the definition of an irrational, you know. But your chapter name, number system chapter name, sometimes in some textbooks it is given as a real numbers. So what is mean by real number? Real numbers are nothing but the combination of a rational and irrational. But what is the standard definition of a real number means? A number whose square is a non-negative is called as a real number. A number whose square is a non-negative number. I mean, for example, here 2 square is there, that is equal to 4. Minus 2 square is there, that is also equals to 4. Root 2 square is there, that is also 4. Minus root 2 whole square also is there, that is also, sorry, root 2 square is 2. And minus root 2 square also is 2. But root under minus 2 whole square is equal to what? This we cannot say. Or you say, what is this means? For example, under root of 4 or minus 4, what is this? We cannot say. Under root of minus 4. So here 2 square is 4, therefore a 2 is a real number. Minus 2 square also is equal to 4, therefore here according to my definition, a number whose square is a non-negative is called as a real number. A number whose square is a non-negative. If you see, these are all positive numbers. Therefore, 2 is a rational. Minus 2 also a real number. And root 2 also a real number. Minus of root 2 also a real number. But here, it will not be accepted. Under root of minus 4 whole square value, we cannot write. Because if you write it is minus 2 into minus 2, it will become 4. Plus 2 into plus 2, it will also become 4. So here, according to these statements, you want to observe one thing. Here, what is that means? 2 is a real number. Minus 2 also a real number. Root 2 also a real number. Minus of root 2 also a real number. Therefore, real numbers means all rational plus irrational. All rational numbers or irrational numbers are called real numbers. So this is the simple definition of a real number. But in real numbers, there are two important properties are there. What are they? In your textbook it is there, but you require to identify those identities in your textbook and you learn what is those identities. In some competition exams he will ask you what is the definition of that particular identity. Here completeness property is one property is there. So what is completeness property means? If you take a number line, so this is 0 and this is 1, this is 2, this is 3, and this is minus 1 and this is minus 2 and this is minus 3. So what is completeness property is saying means if you take any point on this number, if you take any point on this number line, that point is called as a real number. That point is called as a real number. It means what? Any point on the number line, it may be a rational number or sometimes it may be an irrational number. What is it means? Means a rational number we can represent on the number line. In the previous class, I explained how to represent the rational numbers on the number line. And it may be a irrational number, means we can represent irrational numbers also on the number line. What is completeness property means? A point, any point on the number line, it is a real number and it is unique. It is unique. That property we can call it as a completeness property. So this is very, very important definition. So a number line, if you take any point on the number line, it is a real number and it is unique. That point is unique. And another one property is there that is called as a density property. What is density property means? If you take a number line, and you take any two real numbers on this number line, if you take any two real numbers, here this is you say as A1, this is A2. If you these A1 and A2 are the two real numbers, so what is density property saying means there are infinite real numbers in between. two real numbers. There are infinite real numbers between two given real numbers. So it will be converted into another two statements. What are they means? There are two infinite rational numbers between two rational numbers. There are infinite rational numbers between two given rational numbers. There are infinite irrational numbers between two rational numbers. There are infinite irrational numbers between two rational numbers. And there are, for example, these two are irrationals. For example, these two are irrational. If these two are irrational, on the number line, there are infinite irrational numbers between two irrational numbers also. So what is density property means? The density property is nothing but if you take any two real numbers on the number line, there are infinite real numbers in between given two irrational or real or rational numbers. So this is the density property. So by using this density property, we require to do some questions here. For example, I will tell you some simple examples. So here 3 by 4 and 1 by 2. These two are the rational numbers. This is my first rational number and this is another rational number. So you know, according to, we learned in the first class how to write some rational numbers between given two rational numbers. So I already explained the main method. This main method is used to write one rational number between given two rational numbers. And another method I told you, that is single step method. By using that method, you can write the how many rational numbers you require. Sometimes you require 5 rational numbers, 6 rational numbers, 10 rational numbers. For that purpose, you will use the second method. By using that second method, you can write how many rational numbers between given two rational. But here my concept is how to write the irrational numbers between two given rational numbers. How to write the irrational numbers between given two numbers. This is very, very important and very, very easy concept to write irrational number between two given rational numbers. Here, 3 by 4 and 1 by 2 are the two rational numbers. I require to write some irrational numbers between these two. So, there is a simple concept is there, that is if a comma b are any two numbers, a comma b are any two numbers, the first concept is a plus b by 2 is the rational number between a and b. A plus b by 2 is the rational number between given two rational numbers. This method only we can call it as a mean method. But if a and b are two rational numbers, and the second concept is under root of ab is called as a irrational number. So if you want to write the irrational number between a and b, that is under root of ab. So under root of ab is an irrational number between a and b. So these two concepts are very, very important. Every student know that a plus b by 2 is the rational number between a and b. Under root of ab is called as a irrational number between a and b. For example, what is the rational number between 2 and 3? Simple example I am explaining here. 2 is a rational number, 3 is also a rational number. If you want to write a rational number between 2 and 3 means that is nothing but 2 plus 3 by 2, that is equal to 5 by 2 is the rational number between these two. So what is the irrational number between 2 and 3 is according to my formula under root of AB, that is nothing but 2 into 3. So that is root 6. Root 6 is an irrational number between A and B. I mean 2 and 3. So these two formulas are very, very important. Sometimes in exam they will ask you what is the irrational number between given two numbers means you want to apply this formula, that is under root of AB. Here my concept is how to write irrational numbers between given two numbers. For example, here I am going to tell you what is the irrational number between these two means you can write that is under root of AB. So that is 3 by 4 into 1 by 2. So this will become 3 by 8. 3 by 8 is the irrational number between given two. But the thing is, for example, I want to write 5 irrational numbers between these two rational numbers. For that purpose, This is very, very important concept to write more than one irrational numbers between given two rational numbers. Just you do what is the value, decimal value of 3 by 4 by doing the long division. You divide 3 by 4. So 4, 0, 30, 4 8s are 32, 4 7s are 28, and 2 will come again. This will 5s are and 20, so 0. So the decimal value of this one is 0.75. The decimal value of 1 by 2 is 0.5. So the decimal value of the first one is 3 by 4, that is 0.75. The decimal value of 1 by 2 is 0.5. You can write it is 0.50 also. Now, what I am doing means here I am writing some numbers. If you observe carefully, 0.67325131501305 dot. And another number I am going to write 0.672315000135217002 dot. So why I wrote all this? So if you observe carefully, these two decimals are non-repeating, non-terminating decimals. These two decimals are according to, in our first class we defined the different types of decimals. So according to those definitions, we can say that these two are non-repeated, non-terminating decimals. Hence these two are irrational numbers. If you observe these two irrational numbers, this value is begin with 0.67, means it is less than 0.75 and it is more than 0.50. So this value is less than 0.75 and this value is more than 0.50. Hence, this number will be between these two values. Therefore, we can say this is an irrational number between 3 by 4 and 1 by 2. In the same way, if you observe the second decimal, that is 0.72 and something it is there. This is also less than 0.75 and it is more than 50, I mean 0.50. So hence it is also in between these two numbers. So like that you can write infinite irrational numbers. You can write infinite irrational numbers between given two rational numbers. So this is the method to write more than one decimal, I mean more than one irrational numbers between given two rational numbers. So many times in exams, he will ask you to write the rational numbers between two given rational numbers. Sometimes he will ask you write 4 or 5 irrational numbers between given two rational numbers, means you want to follow this method. First you find the decimal value of this one, approximate, sometimes approximate value up to 2 decimals or up to 3 decimals. And then afterwards you go to write these type of decimals and those are the irrational numbers between given two rational numbers. But sometimes we will give you one question is there in your textbook, that is, what is the irrational number between root 2 and root 3? Already root 2, root 3 both are the irrational numbers, but what he is asking, what are the irrational numbers between root 2 and root 3? For example, he is required to ask you, I mean in the question it is given that you need to write 3 irrational numbers between root 2 and root 3. So while solving this, you should know the long division of a square root. How to find the square root of given numbers by using long division. That is very, very important. We learned in 8th class to find the square root value of 2 up to 3 decimals, up to 4 decimals, up to 5 decimals. That is very, very important. That work will be helpful in this class. I mean in this concept. So now, yeah, root 2 and root 3 both are the irrational number. He is asked to write 3 irrational numbers between root 2 and root 3. So you know that the decimal value, approximate decimal value of root 2 is 1.414. You know that. So this is the root 2 value, that is approximate decimal value up to 3 decimal places, that is 1.414. And you know that what is the root 3 value up to 3 places means 1.732. So this we know. This is the root 3 value, that is 1.732. And this is the root 2 value, this is 1.414. Then he is asking to write 3 irrational numbers, means now what, 1.56234 00213 dot dot dot. If you see this my number, it is in a non-terminating, non-repeating decimal. Hence, it is an irrational number, and it is more than 1.414 and less than 1.732. 100% it will in between these two values. I mean, it will between root 2 and root 3. Next, I will write 1.6230021156 dot dot dot. This is also an irrational number because it is not terminating and not repeating. Hence, it is also in between these two numbers. So, this is also very interesting. Like that, you can write how many irrational numbers you require. So, this is one pattern question. It is given in your textbook. So, these are the things here in this class. I explain what is an irrational number and how can we define an irrational number. I have given two definitions for the irrational numbers, and what is real number also I explained you. And here I explained the two properties, that is completeness property and the second one is the density property. And by using this density property, we find some irrational numbers between two rational numbers and between two irrational numbers. So these concepts are very, very important. And another concept also I explained, if a comma b are any two numbers and a plus b by 2 is a rational number between the given two numbers, that is also very, very important. If a comma b are any two numbers and a plus b by 2 is a rational number between these two, this is a rational number, and a comma b are two numbers, under root of ab is an irrational number between a and b. By using these concepts also you can find the irrational and rational numbers between given two numbers. And afterwards, how to find the irrational numbers between given two rationals and given two irrationals. So what technique and what rule you want to find for use to write more than one irrational number. You write more than one irrational number between given two rational and irrational numbers. By using their decimal values, you can write infinite irrationals and infinite rational numbers and between two given numbers. So this is the concept of number system. This is one of the important concepts in the number system. And the remaining things we will learn in the third part. That is also very, very important topic. Thank you.